Hello students, I Dr. Shah Ubaidullah from Degree College Baramulla welcome you all to this first lecture on biostatistics. This is the unit 4 of your syllabus of semester 2 bioinformatics, and in this lecture I shall be discussing the basics of biostatistics, or I will introduce you to the subject of biostatistics. Let me share my presentation with you. So, biostatistics. So this is lecture 1, and here we shall discuss, as I have told you, I will introduce you to the field of biostatistics. What is biostatistics? And these days, as you all know, we are facing a pandemic which is known as COVID-19 pandemic, and daily we come across the data such as how many active cases are there, how many have been discharged from the hospital, and how many deaths are taking place due to this COVID-19. So what actually we are doing? We are collecting the information about the active cases, then how many cases have recovered or how many deaths have taken place, and we represent this data. And we come across this data in newspapers, news, or any other media. And daily we are concerned about this pandemic, and this data, it gives us how deadly this pandemic is, how many active cases, how many people are contracting this disease, how many people recover, what is the increase in the recovery, how many active cases are the active cases increasing or decreasing, and how many deaths. Do we face more deaths or decrease in the number of deaths? What we are actually collecting the data and presenting this in the form of information to general public, or on the basis of this information we devise our strategies, whether we have to go for the lockdown, what are the strategies, do we need vaccination, or do we have to go for herd immunity. Everything will be decided by this data. Then we also come across this curve, which gives us the increase in the number of cases. Right here, we have shown this curve from Feb, when the first cases were detected in India, starting, though this pandemic is started in December in China, but in Feb, the first case was reported in India. Now we are daily seeing this type of curve, that this curve is increasing. That means the number of cases reported daily, they are increasing. Something is decreasing here, that is daily new that deaths, it is decreasing. So again, we use this data for designing our strategy. We come across this. But what is actually this? We are collecting the information from the ground. We are daily monitoring how many new cases have been reported, how many deaths have taken place, how many people have recovered, and we present this information in the graph, in the form of a graph. This is nothing. This is statistics, or we call it biostatistics, since we are applying the principles of statistics to a live problem which we are currently facing, which whole world is currently facing. So in this lecture, we shall be discussing about what is statistics and what is biostatistics. So first we will see the word biostatistics. If we look at this word, it is the combination of two terms, that is bio and the statistics, and this forms the biostatistics. What is statistics? Let us look first as what is statistics. So statistics is a field of study which is concerned with collecting data. In case of pandemic, what we do, we directly see how many people are contracting the disease daily, how many people have recovered, how many deaths have taken place. So we are collecting the data from each hospital, from each lab. So this is collection of the data. Then we organize and summarize data. We organize the data, how many new cases, how many deaths, how many people have recovered. So this is organizing and summarizing the data. Then we interpret the data. How many new cases from yesterday? How many new cases from Feb? How many new cases from November? How many new cases in December? How many deaths were taking place 2 months ago? And how many deaths are taking right now? How many people recovered first? And how many people are recovering now? So we are interpreting this data. And then we analyze data. Analyze means, is there increase in the death rate? Is there increase in the recovery? So this is analysis of the data. And then we present the data in the form of charts, in the form of graphs, and then we make decisions based on the data. Where do we need vaccination? How much is the recovery rate? Is it increasing? If recovery rate is increasing, then it is good for us. If recovery rate it is not increasing, there is more death rate, maybe we have to take other measures. We may have to go for lockdown or other strict measures. So statistics is collecting data, organizing data, summarizing data, then we interpret this data, analyze this data, present this data, and make decisions based on this data. All these constitute statistics. And collecting data, understanding data and numbers, and translating this uh, into information constitutes statistics. Again, we have represented this COVID-19 tracker. We have seen how many confirmed cases, then we will look for the active cases, then how many have been cured and how many deaths. So we have collected this data and we are presenting this in the form of information. So this is statistics, or I can call it biostatistics. Since we are applying this to a life problem, we will call it as more appropriately as biostatistics. So what is the scope of statistics? It can be used in the field of agriculture. We want to estimate our produce. We want to increase our produce. How much pesticides we require? How has the use of pesticides increased our yield? Then again, we can use it in our industries to estimate the costs, to see whether we are gaining or we are at loss. Then in education, we can see how many people are being educated, how many girls, how many boys, what is their background, what is the gross enrollment ratio. Then we can use also it in the form of economics, as we already see these trends, so whether our market is gaining, it is losing, how many points up, how many points down. Share market, you must have been, if you watch these things. Then we can plan family budget or the budget of our country, of our school, college, etc. Then market research, what is the new market research, which product is being liked by the people, which is not. We can go for the reasons. We can do the trend analysis. What is the trend in the market these days? Or similarly, if some students, they are taking up a certain subject, then we can apply statistics. How many are taking? What was the percentage of students which were offering this subject last year? Has it increased? Has it decreased? Why it has increased? What is the effect on the market? If employability of a subject is more, we will see more people, more students taking the subject. And we call statistics is the science of data, or the tool to study data. Actually, what it is actually data we are seeing, but how do we study it? We have the tool which is known as statistics. So here we have represented, first we go for the data collection, then we apply statistical tools and transform this data into the information. This is statistics. So if we look at the biostatistics, it is the application of statistic tools to the biological data or the life problems like public health, like the example of COVID or any other disease, for example, diabetes, obesity, what is the incidence, what are the causes, and then medicine. If we have a new medicine in the market, what is its effect on the people, or how much is it efficient, what is its efficacy. Then ecological or the environmental parameters we can access, increase in pollution, decrease in pollution, what is the effect of the pollution on the organisms there. So all will be taken care by biostatistics. And then the question is, why biostatistics? in why biostatistics. For example, we want to measure mortality, that is the death rate, or the morbidity, that is the number of people being affected by a particular disease or a particular problem. So we want to measure. So we use biostatistics. We want to identify risk factors of a disease. For example, we want to see what is the cause of diabetes. So we are identifying the risk factors of a disease, or estimating the efficiency of a treatment. Like in news, you are currently seeing the efficiency or efficacy of the uh, COVID-19 vaccines. It is around 95%. How it has been measured? Since it is, again, we have collected the data and then estimated the efficiency of this treatment. Then we design and monitor, interpret reports of a clinical or a related stage. For example, we want to study the effect of a particular drug in a certain district. So we design our studies, then we monitor, analyze, and interpret the reports, and then devise our future strategy. And then we also develop statistical methods to address questions arising from medical or the health data. When we collect this data, and then how to address the question, it also comes out. And finally, we want to improve the health status of the population. So we apply biostatistics and then devise and design our strategies. What are the steps we should take to improve the health studies? All this involve biostatistics. Then we shall look at the basic terms which we will come across in the field of biostatistics. So first is measurement. Measurement is just simply assigning the numbers to something. We are measuring the number of active cases. We are measuring the deaths. We are estimating how many people are recovering. So it is all included in the measurement. The next is data. Data is nothing. It is collection of the measurement. We are going to different labs and then collecting data each day. How many people are being infected? What is the recovery rate? How many deaths have been reported? So it is collection of measurement constitutes the data. Then sample. Our sample is collected data. Collected data is our sample. For example, in case of COVID, our sample is all the patients which come to labs or to certain hospitals. Since all the people don't reach labs, so all is not sample. But sample is something out of population. For example, we take the population of J&K, we take population of our country, India. Then we estimate how many people have contracted the disease. This constitutes the sample. Then population is all the possible data. For example, population of J&K, it will constitute the population, and how many people are being infected, are being treated, it constitutes our sample. This shall be clear in next lectures as well. Then we have the variable. Variable is whose value changes, property with respect to which data from a sample differ in some measurable way. For example, a person died, this data it is different from the person who has recovered or the person who has just got a disease. So this is the variable. Then let us make a distinction between population versus sample. As I have said, population of whole country or whole J&K, it will constitute the population. Then out of this, we select some few people as our sample, where we estimate their height, their age, have they contracted the disease. This will constitute our sample. So population, it is an entire set of possible observations in which we are interested. For example, we want to study the effect of a particular drug in J&K. What is the incidence of diabetes in J&K? So whole population of J&K will constitute our population. But out of this population, since it is not possible to take each and every individual, so what we do, we select certain individuals which we call as the sample. And on the basis of sample, we make our observations. So sample, it is a subset of the population from which information is actually collected. For example, we want to see the incidence of obesity. We want to see the age. We want to see what is the weight, what is their diet, what they take. Do they take excess salt, excess sugar? So it is not possible to study whole population. What we select a subset of the population, and this subset is called sample. So whole population, we select a few individuals which constitute our sample, and on the basis of sample we get the results of the whole population. We say that incidence of diabetes in J&K, it is around 1 in 10 people is having diabetes. So what this study, it is based on the subset of the sample, and it gives us inference of the whole population. Then why do we need sampling? Because it is difficult to obtain the information from the entire population. If we want to go into each and every individual of the population, then it will be time consuming. We will need money, huge. Then manpower we will be needing to reach to each and every individual. So what we do, we just choose a sample. On the basis of we study the sample, and we can infer the results of the whole population. So we rely on the sample to make estimates or inferences related to the population. But sometimes, for example, now we are estimating the population, what we call census. So census, a sample that contains all items in the population. Here in census, what we do, we have to estimate the population. So what we do, we try to reach to each and every individual that will constitute the census. So census, a sample that contains all items in the population. While a sample, it is a subset of the population, and on the basis of the studies of the sample, we infer the results of the whole population. Then we come across two more terms, data or the variable. So what is data? Variable are the properties or characteristics of some event, object, or person that can take on different values or amount. For example, we are interested to study the height. So height, it can be 5 feet, 5.5 feet, 5.6 feet, or we want to see the relation between height and weight. Then we will measure height and the weight. So this height and weight, it can have different values for each person. So this is data or the variable. And characteristics on which population differ from each other. For example, we have said age. Now my age may not be same as that of my colleague. Your age may not be same as that of your friend. So age can take any value. Then sex, we have two sexes, or we may have third. Then hemoglobin value, if we want to measure, it will be different for different individuals. Then blood groups, again, they show the variation. So this constitutes our data or the variable. Data is anything which can take any value, and same wise sometimes it is also referred to as variable. Data and variable are not same, but sometimes they are used as synonyms. The observations made on the variables is called data. For example, I want to estimate, I want to check, I want to record the weight. So I am recording the weight of each individual. So the weight is variable, but the information I am collecting is data. So again, these variables may be quantitative or qualitative. Quantitative means where we get the actual value, and qualitative means where you can say yes or no. Quantitative means when measurement of any characteristic is possible on a scale in some appropriate units. For example, we measure height, maybe in centimeters, maybe in meters, maybe in feet, then weight in grams, kilograms, and so on. Then we can measure age or IQ, we have the scales. So this type of data will be the quantitative data. Then if we go to the qualitative data, again, if qualitative data means, for example, if we want to see boy and the girl, so this is qualitative. Then sex, for example, boy or the girl, male and the female, this is qualitative. We want to see smoker versus non-smoker, again qualitative data. Obese person versus non-obese person, qualitative data. We can't measure how much obese. We can't assign any value to smoker and the non-smoker, but we can just make the distinction. So this is qualitative. Again, this quantitative variable, it may be discrete or discontinuous variable. That means where the values of variable differ from one another by definite amounts. For example, number of individuals in the population, it can be 5 or the 6, or we can see boys or the girls in a class, it can be either 20, 21. It can never have a value like 5.5. So we call this as discrete or the discontinuous variable, where They differ from one another by definite amount. And if we talk about the number of individuals in a population, each will differ from another by one. We can have 5 persons, we can have 6 persons. So the difference is one. We can never have 5.5%. So this type of variable is known as discrete or the discontinuous variable. If this type of variable, it can't take any value, but it will only take a discrete value. So then we have the continuous variable. They can take any value within the range of the scale. For example, height can be 4.5 meter, it can be 4.6, it can be 4.7, it can be 5, it can be 5 meter. So it can take any value. So such type of variables are known as continuous variables that can take any value. Then if we come to the qualitative variable, these are those variables which can't be measured. For example, I have said about the smoker versus the non-smoker. So we can categorize them into smoker and the non-smoker. We can categorize into male and the female. So this type of variable is the qualitative variable. It can't be expressed in magnitudes. For example, sex, color of a flower, smoker and the non-smoker, or in genetics we generally use wrinkled and smooth seeds. So the capital R represents the wrinkled and small r represents the smooth seeds. It is just a qualitative variable. We can't assign, it can't be measured. Then we come across one more term, primary data. So what is primary data? Primary data is data that is collected by a researcher from the first-hand sources using methods like surveys, interviews, or experiments. For example, I go to the class and then I collect how many use internet, how many have the facility of the broadband, how many are able to access the material which we are sending through the Google Classroom. So this data I'm directly collecting from the students, which are my first hand sources. So this type of data will be known as the primary data. And we may use surveys, I may interview people, or we may use experiments to collect data. So this constitutes the primary data. It is collected with the research project in mind directly from the primary sources. Primary sources in my example are the students. So I am directly collecting the information from the students. So this will constitute the primary data. Then we have the secondary data. Secondary data is the data that has already been collected through primary sources and made readily available for researchers to use for their own research. It is a type of data that has already been collected in the past. For example, I collect from data from you, how many have a broadband facility, how many have 2G, how many have 4G, how many use internet. Now I compile this data in the form for my own purpose. Now for example, now my principal asks me, my principal takes this data and he uses this in his own presentation. So for my principal, this is the secondary data. This was readily available from me, so which I have compiled. So this type sources of secondary data include books. If I go to some books, then I see some data there and I quote it. Then personal sources, journals, newspaper, website, government record. This all constitutes secondary data. For example, now this COVID data, it has been collected from the patients. Now it is available in the print media. Some other researcher uses it for his own purpose. It will constitute the secondary data for him. Secondary data are known to be readily available compared to that of the primary data. Primary data has to be collected, and secondary data, it is already collected and someone uses it. So this is the difference between the primary and the secondary data. So these are the terms. This is the first lecture of this introduction to biostatistics, and I have discussed some of the terms which will come across while we study this chapter. Thank you for your kind attention, and thank you.